Hello students, welcome to Database Management System class. Today we are discussing about Unit 2, that is data modeling using the entity relationship model. Welcome to the class. In the last class we discussed about the 4 different phases which we will be following during the design of the database. That is the requirement analysis phase, where we will be gathering information from the user with respect to the design of the database. Next is conceptual phase, where the requirements, whatever we gather from the user, are converted into high level pictorial representation by using entity relationship model. Next is logic design phase. The high level conceptual model has been converted into low level model, that is up to the logic level, which is further carried out and used by the developer to design the database. That is our last phase, physical design phase. And continuing with the topic, today we will be discussing about a simple database application and example to demonstrate how the requirement from the users are collected and how it's been converted to high level conceptual model, that we will be discussing with an example of company database. Next, a brief introduction about entities and attributes. What is the meaning of entity? Why are we using the terms entity and attributes in our class, in database design? All those things we're going to discuss today. In order to start a simple database application, the first step is to list out the data requirements for the database. Like whenever a user wants a database to be designed, he orally dictates what are the requirements he is expecting from the database. Now the developer, the database designer, has to collect the information from the user in requirement analysis phase. Say suppose a person or a user wanted to design a database for company which contains details about his employees, departments, projects and the dependents. We look into each one of these further. In this, let us assume like a user who wants a database application for his company. So what he'll do, he'll go to a database designer and he'll say the requirements whatever he is expecting from his database. And once the designer collects the requirements from the user, what is he going to do further? We'll be looking at now. We'll be looking at here. Once the requirements are gathered, the second point, we describe company as a sample database application. After the requirements collection and analysis phase, the database designer provides the following descriptions to the miniworld. Once the data has been gathered from the user, what he does, rather than writing in common English words like what are the requirements that the user is expecting from the database, what he'll do, he'll try to present it in a conceptual way. That is a higher model where it's very easy for each and everyone to understand. That is the next step, that is he has to create the conceptual schema step by step. That is what we are looking at now. For company database, it has to keep track of the company employees, departments, projects and the dependents. See what happens? The user has told orally to the developer what the database has to do with respect to that company. After gathering the requirement from the user, the developer has developed or else he has analyzed the requirement from the user and is recorded in a document in a precise manner. Now he's going to start the development. That is, he's trying to put the requirement in a conceptual way. If I consider the company database as an example, see, the last point it says, it highlights that the company database, it has to highlight about the employee detail, the department's details, the project details, and the dependent details. We look into the company employee details now. See department. The company is organized as a collection of departments. See, company can have many departments, right? Manufacturing, testing, analyzing. Company can have many departments. But even in the testing, we'll be having like quality assurance tests and maintenance testing team, quality assurance team. So each and every department will be isolated from other department, and all department will be doing their corresponding work. Now we are given a task to develop a database with respect to company, and in that we are concentrating on department. See, each department, it can have a unique name and it has a unique number. Each department is supposed to have a unique name as well, because I can't say we have a development team and we have a testing team, we have analysis team. Each name of the department is unique here. Unique in the sense it's different. The word unique says no two things have the same name. Uniquely identified. For example, your register number, it's unique in nature, meaning to say no student has same register number, right? The same thing, here department has, each and every department is supposed to have a unique name, and the department is supposed to have a unique number. For each and every department will be given a number. This number will be used to identify a department uniquely. Then each and every department is associated with a set of locations. One department will be there. Like for example, if I consider ISRO is located at many places. To which branch are we pointing out? ISRO is in Bangalore, ISRO is in Hassan as well. If I refer to ISRO, to which branch am I referring to? Is it a ISRO of Bangalore company? Or else is it a ISRO which is located in Hassan? So even the department, it's associated with a set of locations. Next, it has a particular employee who acts as its manager and who assumed that position on the same date. And department has a set of employees assigned to it. Lastly, department controls a set of projects. Project could be anything. Like if it is a company, we can get n number of projects. Assume that, just for an example, just for comparison, you assume you are dealing with the manufacturing of the automobiles. See, in automobile, it's not like everything is manufactured under a single roof. Each and every component could be manufactured by different person or different places, and finally all these components are assembled to form a single component, that is our automobile. And each and every department will be handling many projects, will be working on a particular project, or else A department can work even on 2 or 3 different projects. So all this relationship, all these requirements, it has to be handled properly. So after discussing with the user, the database designer, he came to an assumption, or else we can say in order to design a company database, these are the assertions or these are the requirements, whatever we have assumed, even before starting our actual development, saying that the companies are organized into a collection of departments, where each and every department has a unique name, the unique number, and a location associated with it, manager, and department means employee should be there, and even department means employee should work on few projects, right? And what is this picture next to it? So it's an ER diagram. We'll be discussing in much detail further, just for pictorial representation. For easy understanding, I have represented here. I have given just an example. Like department can have location, name, number, manager, and manager start date. Further discussion we'll be doing in further classes. It's just a comparison. Whatever it's written in English words, the same thing is been depicted pictorially here. This is all about department. And next we'll discuss on project, like what are the prerequisites with respect to project. Here either you look at the English phrases or else look at the diagram, both depict the same, saying that the project has unique name and project has a unique number. See, whenever I say unique, even in diagram you could observe there's an underline below name and this is an underline below number, but we don't have any line below location. All these are representation, the way we are going to represent the user requirement in our ER diagram. Whatever it's shown in figure, it's an ER diagram, that is entity relationship diagram. We'll be discussing further. Just for your understanding's sake, it's a pictorial representation saying that the project has something like name associated to it and a number. Both are unique in nature, and it has a single location. It has a set of employees working on it, and it's controlled by a single department. These are the assumption what we are making in order to develop a particular database. See, the assumption can change or the requirement can change from application to application or else from nature of the work. Here whatever we are designing, that asked us to design a company database, and these are the requisite or assumption we are assuming. To summarize, the project, it has a unique name, unique number, location, and a set of employees working on it, as well as a department who can control over the project. Next is a company, it can have an employee as well. Employees are the main heart of the company. What are the details that can be stored in database with respect to employee? See, employee can have name and an SSN or else a unique identification number. SSN is as similar as our Aadhaar number. It's used to identify a person uniquely. An employee can have address. The address it's been stored. Address has to be stored in the database. And the salary, how much we are paying. The gender, the birth date, and under whom is working, that is the direct supervisor, and how many are who are all working under that particular person. There is a set of, it's a dependence. I'll come to this dependent later. And to which department he is working. And the works, the number of hour per week the employee has been working. All this is recorded in the database, and it has to be recorded in the database. As I said previously, in the diagram you can see that is a line below SSN. Please pause the video and just observe. Do I have line apart from SSN, does any attribute as line here? No. Why? As I said previously, SSN is the only sentence. Here, I'll go for the sentence. SSN is the only line which says unique identification. So, even in a group of students in your class, in order to identify a single student, we'll be using your register number. Why register number? Why can't I use name to identify or call a particular person? See, if there is a limit over the number of the students, or else the head count is countable, then it's very easy to identify who is who. And we can identify through name also. But imagine if there are n number of students, enormous number of students, and in your class itself you can observe 2 or 3 students or more than 2 students can have same name. And further, if you go further, the students can have same name as well as the initial, same initial. So it will be highly difficult for us to identify or differentiate between these two. So the best way is to differentiate or identify a particular person in a group of person is to use a unique identification number. The same concept will be applying, and we'll be using register number to identify each and every student. Similarly, the Aadhaar number is unique in nature. We'll be using Aadhaar number to identify each and every citizen. That is unique. If I give the Aadhaar number, that belongs only to you. That belongs only to you. It's not like that Aadhaar number cannot be assigned to other number. It purely belongs to a particular only one person. Here SSN is also a number which is assigned to only one person. So that will be used to identify a particular employee in a database. Next, set of dependents. See, company means employee will be working in a company, and you might have heard if someone has spent, if someone like in a family, if someone falls ill or he got admitted to some hospital and is in serious condition, so he is supposed to admit for a number of days and spend huge amount of money, and you might have heard people discussing like they have claimed or medical reimbursement had happened. Means whatever they had spent, the insurance people, they have paid them back the whole amount of money. If you have medical insurance or something, whatever money we have spent on checkup or medical treatment, that money will come back to you in case of insurance. That insurance you have to take. That is like, not all company, but few company gives an options of opting insurance. Say suppose a person is working in your company, assume for example, assume a person is working for a particular company and that company gives an option of health insurance to the family members belongs to that employee. Now that employee, he has to give details of who are the dependents on him. Either it could be a father or mother or children. See, now the employee father, is he working in the company? His mother, is she working in company? Or children, are they working in company? No. Then too, their details are stored in the company database in order to track, because the next day it should not happen the employee takes some advantages of whatever medical reimbursement is been happening. So the company records the dependents who are all depending on a particular employee of the company. Now those dependents are not directly working in my company, but those details are stored. So what we do, for them we maintain a separate entity called as dependent. Even the dependent, assume employee has set children's whom he want to enroll their names in the dependent part. So in the dependent part, it will be like, it can has its first name, the name of the child, the sex of the child, is she male or female, the date of birth of a child, and how is he related to the employee. For example, is he giving in name of a child, or the spouse, or parents, or even sometimes it applies to pets also, and is uniquely identified by a combination of her or his first name and the employee of whom he is depending on. So this is the main point you need to observe here. The employee is directly working in the company. So there is an employee ID. The company is given for an employee, with the help of which I can identify an employee very easily. While coming for the dependent, take an example. Employee 1 has 2 children, and employee 2 also has 2 children. Employee 1 has named his children as Ram, first child as Ram and second child as Shyam. And employee 2 even has 2 children, where the name of the first child is Ram and the name of the second child is, assume it's some ABC. Now both the employees has a children by name Ram. If both the employee want to enroll the name of the students in the company database, there might be a confusion by looking at name of the children, because at 2 places we have an entry for the name Ram and Ram. How can I uniquely identify which Ram belongs to employee 1 and which Ram belongs to employee 2? So the best idea, they are doing here, they're combining the name of the employee, that is the ID of the employee, with the name of the child. If I write employee 1 dot Ram and employee 2 Ram, it's very easy for me to identify the particular Ram, does he belongs to employee 1 or employee 2. Meaning to say, these dependents, whatever we are storing in dependent, it is depending on the employee in order to identify the particular tuple in the database. So once we have decided the constraints, the requirements, what are the design that are to be handled for the company database, next we will be focusing on our design part. In order to design, we will be using entity relationship model, that is YA model. The focus is on the second phase, that is conceptual design. Entity relationship model is a popular high-level conceptual data model. As we discussed yesterday, it's a popular high-level conceptual model because whatever we studied previously, those English words are pictorially represented. I'll show it in next slide. By looking at which anybody can understand like what will be the database composed of and how it will be built further. For that we'll be using YA diagram, that is entity relationship diagram. ER model describes data as entities, relationships, and attributes. In further classes, we look at these terms. What do you mean by entity, relationship, attributes? Don't bother about the terms and don't go with the terminology. Just understand that ER model will be concentrating on entities, relationship, and attributes. See, whatever we discussed previously, the same thing has been represented pictorially here. We have employee, we have department, and below to department we have project. And lastly, we have dependent. In red color, we are highlighting the attributes, entity, and relationships. For time being, be noted that the eclipse, whatever I am writing in the eclipse, that represents attribute, and whatever we are writing it in square, that is going to be our entity, and whatever it's written in diamond box, that is going to be our relationship. See, by looking at diagram itself, I can say entity means it is represented by rectangular boxes, that is employee, department, project, and dependent. And we are describing entity with the help of attributes. Just observe, go with an employee. For employee, we have attached a number of eclipse. Say we have SSN, date of birth, the name, address, salary, sex. Like it's describing the features or the qualities or the features, that is going properties, the set of properties that is going to represent my entity name. Similarly, for the project, say we have name, the number, the location. Those are all the properties that are represented in eclipse, and it is going to describe the property of an entity. And relationship, it's self-explanatory. It's going to explain what kind of relationship it's there between two entities. Say between employee and department, we have a relationship works for, meaning to say employee works for particular department. Easy to read. By looking at picture, it's very easy and it's very self-explanatory than representing in high-level English words. When you represent the design model in pictorial representation, it's very easy for a designer to understand. It's very easy to explain the same thing to the user, and if you want any changes, you can easily make it in AR diagram, whatever the changes the end user is requesting at, and it's very easy to analyze what comes under whom and what are the relationship among the entities and what are all the properties that is going to describe a particular entity. This is the basic ER diagram which represents the company database, where we have employee, department, project, and dependent as an entity set, and eclipse, whatever we have written inside eclipse, that are the set of attributes that will be describing the properties of our entity, and the diamond shape that is going to represent the relationship between the two entities. And next we are going to discuss about, as we discussed previously, next topic is about entities and attributes. As we discussed previously, entity means what? It's a thing in the real world with independent existence, and it may be an object with a physical existence. For example, employee, department, project, person, car, house, etc. Whereas attributes, they are the particular properties that is going to describe our entity. Those are nothing but our attributes. For example, employee name, age, address, salary. See, any object you consider, that will be our entity. For example, our daily life, say suppose car. Car is an entity. What type of car? Is it in the color and the type of engine and the model, the price? Those things, it's going to describe the car. And those are considered, the color, the price, the model, everything is considered as attribute, whereas car is considered as entity. So entity is what? It's a real world object. Whereas attributes is a property that is going to describe our object. And next class we are going to discuss in much detail about this entity and attributes. And that's all for the day. While coming for the MCQs, the kind of question it could be asked is like in descriptive directly, they might ask you to draw or design the database ER diagram for company database. And if we come for MCQs, like our first question is, if you are collecting and storing information about company database, the project name would be considered as, see here, project, employee, dependent and department, they are set of entities, but they are asking us project name of the project that is going to describe the property of a project, right? So the project name is nothing but what here? It's an attribute. The next question, the same thing. If you are collecting and storing information about company database, the department would be considered as, here they're asking for department. They're not mentioning department number or department name. They're highlighting the department, what would be the department is pointing to. So department will be considered as entity. Next is ER model describes database. See, while representing entity relationship model, what are we mainly focusing on? What will be pictorially represented? What are we technically terming them as? Given options are entity, attribute, use case. See, we studied something about entity and attribute, but we never encountered something called use case. This use cases come under human language. That is a different thing. But here we are concentrating on the relationship, the attributes, the entities, and even on the participation. We have not discussed about it, the full total participation and the partial participation. In further classes we are going to discuss, but in the given option, the option C suits the best answer. Therefore, relationship, attributes and entity is the correct answer. Next, an object with a physical existence, as we just discussed. An object with physical existence is nothing but what? Entity. Next, the particular properties that describes an entity. See, previously an object itself is called as entity. Now, which a property that is going to describe an entity is called as what? It's an attribute. Sixth question. ER modeling technique is a given options: top-down approach, bottom-up approach, left-right approach, none of these. See, while designing ER modeling, what happens? First, we are going to collect the requirements from the user. Once the requirements are gathered, then we are going to develop conceptually, like high level model will be designing, like what are the requirements that's been required, that's been asked by the user. And later the same thing will be converted to schema and finally to relations, that is tables that could be stored in our database. See, we collecting the requirements, and lastly we going up to our coding part. This is like top down approach. It's not like we are taking the tables and we are trying to extract what it's been stored in the table and trying to develop a schema and trying to extract or gather or analyze what the schema is representing in a ER diagram. That will be like reverse process, which is considered as bottom up. But now what are we doing? We are doing it from higher level to the lower end. That is first a higher detail. It's been collected from the user. That is why it's like top down approach. The best answer, the correct answer for this question is top down approach. And where are we using this left right approach? See, in further classes, you'll be studying about algorithms, you'll be studying about compilers, where the compiler will be using L attribute, S attribute. Algorithms, they are kind of BFS, DFS, where the nodes are passed from top down, left to right approach. In those questions, in compiler design and in algorithm, we'll be discussing left right approach. But ER diagram, it mainly concentrates on top down approach. Next, the overall logical structure of database can be expressed graphically by given options: entity relationship model, relational model, object based model, semi-structured model. All this class we've been studying about entity relationship model, that is used to represent the requirements or the database structure pictorially. We'll be using ER diagram, so option A is the correct answer. The logical structure of database can be expressed graphically by ER diagram. Here ER stands for, as we know, ER stands for entity relationship. So answer A is the correct answer. So that's all for the day. We'll wind up here. Our next class will continue. Thank you all.